It's just continuation of working with various
in progress.
trick expressions. So we're gonna get this worked out a little by little, and then we're gonna return back to the story of equations again. So turns out that exercises in the section 7.4 should be familiar from the point of view of those identities, or sometimes we'll call them as definitions of various trig functions, such as a tangent, cotangent, and etc. So these are ones that we already utilized. For example, Pythagorean theorem and its cronies, such as a tangent squared plus 1 or cotangent squared plus 1. So all that we're going to look at here, and we're going to have some more things in addition. For example, if someone says, how about if you try to prove trig identity or establish it with the example 2 that has a product of cosecant and tangent on one side, and on the other side of this little equation we have secant. So it turns out we need not to solve any equations here, but we need to show that left side produces the right side. And for that, I can start on so-called left side and rewrite cosecant as 1 over sine of angle theta here, and tangent as a sine divided by cosine. So I just use definitions of these two functions. So when we roll them in a form of with sines and cosines, then I can actually cancel and notice that my right side of this identity, which is a secant, is exactly what I just produced. So the idea is we don't solve anything for theta because we actually have identity. In other words, if x is equal to x, then any number that you can place instead of x on the left side will also be equal to itself on the right side. So there are infinitely many solutions. That's why this is not an equation. It is identity that works for every defined theta. And that's important to realize and give it a little thought, because I know sometimes people try to solve it and just get nowhere, because this is not an equation. The question is to prove that it works. And you can see here in examples like one above how they work out these by factoring numerator, like a difference of two perfect squares, as a product of a sum multiplied by the difference. And then for denominator, they see that tangent is a common factor, so they take it out. And then they end up with exact same parentheses that they can cancel. And whatever is left, or actually I should be careful, they cancel not the second, but not the first, but the second parentheses, right? With a minus. And that way they get whatever remains for the answer. So I guess we're gonna practice more in this section, working on the left side of some identities and sometimes moving to the right side, or sometimes working on both sides at the same time. And this is just nothing else but improving various algebraic skills. So the story of this section starts at exercise number 19. So I will be selective by choosing some problems and trying to keep them simple, to simplify them. So let's say if I start with exercise number 25, that messes tangent, cotangent, and cosine and sine. So in this type of exercises, the standard way is to write everything using sines and cosines. In other words, my left side, so here's the left side and here's the right side. So I'm going to try to produce a right side by simplifying my left side a little bit. So let's see what we're going to get. Tangent is a sine over cosine, and cotangent is a cosine over sine. And I like that because it looks like everything is going to nicely cancel here. So when I subtract square of a cosine, then I can see that we really end up with 1 on the left side, subtract cosine squared of u on the right side. And this reminds me of something real nice, something my favorite, this Pythagorean theorem that we already saw today that says that square of sine and square of cosine is equal to 1. So can I say that this is same as a square of sine then? So it looks like we produced exactly what's on the right side, square of sine. So looks like one just needs to start working on it. And the advice is always start with the part that looks more complicated and start simplifying it. It's a lot easier to simplify something rather than to take the smaller piece and start to expand it. But either way will be fine. So let me try another one here, number 37. I'm selecting these problems pretty much at random. So if you feel like doing some particular exercise, just let me know. So in the problem number 37, I have left side here. I try to put L and S, maybe kind of hard to understand. So left side, that's what I'm gonna start with. And I'm gonna take this left side and turn this again in sines and cosines because that's what the right side has. Secant. Secant is 1 over cosine of that angle minus tangent, which is sine or cosine. Please notice that when I wrote this with a sines and cosines, it's much easier to see that we get 1 minus sine on the top because denominator is common and it is equal to cosine of u. Now, I always want to pay attention to what my goal here is. My goal is on the right, and my goal has 1 plus sine of u on the bottom. So the question is how I can possibly produce 1 plus sine of u on the bottom. And the answer is you can just multiply it by 1 plus sine of u, and on the top and on the bottom. So you technically multiply this fraction by 1. But doing this, I may be able to get something out of my numerator. So when I multiply these two expressions on the top, I'm going to end up with 1 squared minus sine squared. And that's something that, again, reminds me of my favorite expression, because I know that cosine squared is going to be equal to 1 minus sine squared. And looks like that's just what I need. So my denominator for now, I'm just going to copy the way it is. So this is also 1 and plus sine of u. And for my numerator, I end up with a square of cosine that I can write as cosine times another cosine, right? So the cosine on the bottom is going to nicely get canceled. And looks like that's exactly what I'm really trying to find here. The right side of this little identity is exactly the same. So looks like you just need to get a piece of paper, pencil, pen, and start doing these exercises, because if I just look at the problem, probably there is no way I'm going to actually see how to work it out. But usually in a couple of steps, we get the answer. Now, probably you should not go too far into this because they start to be more and more involved with various things, and that's kind of too much sometimes. That's why I would say if you can just do problems on the first like 40 something exercises, that would be reasonably enough, unless you get into plan to get into such a class as differential equations. That's where we actually encounter things like this, because sometimes it takes a little bit of effort to work out these little exercises. So again, if you have any exercise that really attracts your opposite, if you don't like, you can tell me. I can tackle it right now. And in the meantime, I'll take something like 61, for example. So the problems, the farther you go lower, the more they get into various little details. So again, in 61, I definitely want to produce right side out of left side. And again, you already know the plan. Instead of tangent, I put sine over cosine. Sine of, now they have thetas. Maybe I'll put letter U for convenience. I think it's easier to write. But because it doesn't really matter what angle you have, theta or U or X, whichever one you prefer. I think U looks pretty good in terms of writing it down, at least for me. So I just wrote tangent minus cotangent with sines and cosines. And on the bottom will be pretty much same thing, but with a plus sign. So I end up with fractions that have denominators sine and cosine. And whenever we deal with these so-called complex fractions, so the part in complex fractions that always bothers me is having those various denominators, I just have to multiply by so-called common denominator. And the common denominator will be a product of sine times cosine. And I have to multiply and the top and the bottom of this fraction by that. This way, my denominators will cancel. And of course, in order to cancel those denominators, I must distribute. I must also multiply first terms by this product because I distributed over both pieces of my difference. And now I'm going to have a little fun. I love to cancel, so I'm going to cancel all of those denominators because that's the point why I was doing this. So let's see what we're going to be left with. And looks like on the bottom I have sine squared plus cosine squared of u. Please notice that here we have two cosines multiplied and two sines multiplied. And analogously on the top it's sine squared, but now it's minus cosine squared of u. And notice that my denominator is equal to 1. That's my favorite identity, Pythagorean identity. So I don't have to write anything. And we're done at this stage, right? Because that's exactly what I needed in this exercise. So whenever you do these problems, always keep your goal in mind. And the goal is right side. So you just keep checking what's on the right side and try to produce expression as close as possible to it. So we can do another one. I told you that you don't have to do these problems in the rest of the section because they get, some of them might take you a while to do actually, but I'll just try and I hope you'll be able to follow it. Maybe at your place a little later tonight or tomorrow, because that'd be the greatest practice for these, since if you're able to reproduce the same solution, well, then it means that you'll be able to do pretty much any exercise for our class. So let's try another one. I'm just gonna take something and do it, and maybe at that stage it should be good enough. I'll just do one more. I don't think I wanna ask you to do these exercises today for a quiz because it is really too much. But we already know the key idea. Whenever you have all this secants, cotangents messed up with sines and cosines, the plan is to write it all down with just sine and cosine. That's pretty standard. And what if not? What if you have something that looks a little bit different, like say problem number 78, as Alex, it's still sine and cosine. Okay, but I selected 78 because I recognized another structure, sine squared and tangent squared. That's another Pythagorean theorem. In fact, I think it's a good idea if you try to see why this piece works. And in order to see why, you just need to rewrite tangent as a sine over cosine and secant as 1 over cosine, and then you will see that common denominator is cosine, so you write number 1 as cosine over cosine, of course, squared, and then turns out this Pythagorean theorem will be involved. So I think that'd be a good practice for you to try on your place to justify this formula. I think it's pretty interesting procedure that you should be able to do now, but my goal is to see that secant squared minus tangent. Notice if I bring tangent over to the other side, I'm going to have a secant squared, secant minus tangent squared is equal to number 1, right? So let me do 78. I can write this as 1, subtract tangent of v, so I can put u, so v doesn't matter. So tangent is sine over cosine, right? Is divided by secant, which is 1 over cosine. And this complex fraction needs to be definitely cleared with all of its little denominators. And they're just cosines. So again, multiplying by cosine the top and the bottom. And the bottom has just 1 piece, but the top has 2 pieces. So I'm going to multiply each of them like that. So after we canceled, something nice is probably going to come out. And the numerator will have just cosine of u multiplied by 1, subtract sine of u. And then denominator, all we have is just number 1. Is that what we actually needed? And here, one is Alex, it's a plus sign here. So I should be careful because I didn't copy that tangent correctly, right? I put a minus, but it should have been a plus. Okay, so looks like indeed we got the result. So again, for these problems, I guess I'm not going to be asking you to do the quiz, especially problems at the end. You can tackle it if you have nothing else to do over the weekend, but it's a little bit too much. So the next sections will deal with more involved exercises and this type of simplifying algebraic little simplifications, and I guess we'll continue with that next time, because again, the problems here start to be involved, I guess, too much into various algebra. And my goal is not to turn this class into tedious algebraic stuff, but I think that little formulas of the type that we just looked at here on the bottom, you should definitely be able to do if you can follow through problems like 78 and 61, then you should be good with those for sure. So again, I want to remind you, you probably received email already from college to fill the student evaluations. And I guess I just want to make sure that you do this. So maybe I'll let you go today without a quiz and you check your school email. I think they last week should have sent it to you. And there is a link, so just click on it. It's called Class Climate. That's how they name it. So you can try to fill this within remaining class time if you didn't do so. So please give it a little thought. And I'm going to end this today without a quiz. So I'm gonna stop recording.